Well, hello, geometers, logicians, and seekers of general truths. In this lesson, we will learn about logical statements. Okay, so this is the beginning of what's called deductive reasoning, where we use and apply and analyze the law of logic. And so before we can analyze the truth of these statements, we have to understand what these statements are and what they are saying. So let's just begin out with a very simple definition of negation. Okay, and negation means just to take a statement and say the opposite of that statement. So for example, if my statement is the car is blue, well, what would be the negation of that statement? Well, the simplest way to say it is the car is not blue. Now, it might be really tempting for you to, instead of saying not blue, you can say the car is pink, the car is orange, the car is red, but that's not strictly speaking the negation of the statement. Okay, to be precise about this, we can only say that the car is not blue. The other colors we're really not sure, even if we were to negate the statement. Okay. Now, when we talk about logic, sometimes it's important to think of statements that are related to each other. They're not saying the same thing necessarily, but they are related to each other. And one of those is what's called the converse. Okay? So let's say that you have a conditional statement. The converse of that statement is to switch the hypothesis and the conclusion. So for example, if your conditional statement is, if it snows, then school is canceled, then the converse of that would be, if school is canceled, then it snowed. So what we're doing here is taking the phrase school is canceled and it snows and simply swapping them. Notice that we're keeping the if and the then parts of the statement the same. Okay. Now, later on, we will analyze these statements to see if it's true or not. Like, we will come to the question of, are these two conditional statements saying the same thing or not? Okay, and it depends on the various situation. But for now, we simply want to be able to work on the format of these statements. Okay, so along those same lines, another type of related logical statement is what's called the inverse. And the inverse means for us to negate the hypothesis and the conclusion of a conditional statement. So if we have the same conditional statement as before, if it snows, then school is canceled, we're going to keep everything the same, except we're going to negate the hypothesis. We will say if it does not snow, and then we're going to negate the conclusion, then school is not canceled. Okay, so we're going to use this same statement here. If it snows, then school is canceled, as our example for these three vocabulary words. Okay. All right, the third and final related logical statement is what's called a contrapositive. And the contrapositive is kind of a combination of the inverse and the converse. We are going to swap and negate the hypothesis and conclusion of a conditional statement. So let's say our original statement was, if it snows, then school is canceled, just like before. Then the contrapositive would be, we're going to first of all swap the hypothesis and conclusion. If we're going to take the school is canceled part of it and the snows part and swap it, and we're also going to add the word not to both of those phrases. So our contrapositive, if school is not canceled, then it did not snow. Okay, and again, in the next couple lessons, we will get a little bit deeper and we will analyze these statements. Right now, we want to understand what the statements are saying and how do we form one statement when given another. Okay. So let's do a little bit of practicing on conditional statements. And we want to rewrite these conditional statements in if-then form. Okay. When we write it in if-then form, it is a little bit easier for us to interpret and analyze. So let's say our statement is, anyone with a body temperature of 103 degrees Fahrenheit has a fever. Okay. Well, this is actually a conditional statement. There's a condition and a conclusion embedded in this. And the if-then version of this would be that if a person has a body temperature of 103, so this same clause here is saying anyone, so is the same way of saying if a person has this body temperature, then she has a fever. Okay, this is the conclusion of having a fever. A pickup truck is a vehicle with a high utility value. Well, that's the same as saying if you have a pickup truck, or if a vehicle is a pickup truck, then it is a vehicle with a high utility value. Or if you have a pickup truck, then you have a vehicle with high utility value. Okay, so we're taking the conditional statement and we're making a little bit more standard and uniform by introducing the if-then form. Right, and finally, there is something in logic called a biconditional statement. And these statements are very special because they are basically a combination of the conditional and the converse. And we join them together using the phrase if and only if. And this serves two purposes. It not only makes the statements shorter, but it also makes a stronger statement. So let's see an example of that. Okay. Let's say we have a conditional, as we had before. If it snows, then school is canceled. The converse would be, if school is canceled, then it snowed. Okay? Now we can combine those two together and to say that school is canceled if and only if it snowed. And you see, this is a very strong statement. It's saying that snowing and cancellation of school is the same thing, is the same event. If you wake up and you see that it snows, then you know definitely school is canceled. Or if you wake up and you see that school is canceled, then you definitely know something about the weather. Okay, so this is a very strong statement. Now, the truth of this statement depends on where you live and the circumstances of your school. We're not going to get into that here, but we're simply saying that this if and only if version of the statement combines these two together. And in order for the biconditional to be true, then both the conditional and the converse have to be true. So for this third statement, the biconditional to be true, both of the other conditional and the converse have to be true. Okay, so let's practice a little bit more for the given statement. Write the if-then form, the converse, the inverse, the contrapositive, and indicate whether each statement is true or false. Okay, so you should pause the video at this time, try to write these for yourselves, and then check with me. So the original statement is, when it rains, it pours. Well, we can write that as a conditional in if-then form by saying, if it rains, then it pours. And this is false, right? Because it is possible for it to rain without pouring. It could be drizzling or sprinkling outside. The converse is to swap the two phrases. So if it pours, then it rains. And this statement is definitely true. So if it's pouring outside, then it must be raining. The inverse is to negate the hypothesis and negate the conclusion with this word not. Okay, so if it does not rain, then it does not pour. And this is also true, right? Because if it's not raining outside, then it can't be pouring outside. Okay, pouring is a condition, it's just the form of hard rain. So if it's not raining at all, then it's not raining hard. And lastly, the contrapositive. If it does not pour, then it does not rain. Okay, so this is a false statement because if it's not pouring outside, then it may still be raining. It's not necessarily true that not pouring leads to not raining. So hopefully this is some good practice for you. There are other examples in the notes that you can use to do some more practice on this. And now we're going to move on to the last part, which is for us to analyze and rewrite biconditionals as if-then statement and the converse, and then determine whether the biconditional is true or false. So our statement, biconditional here, is a person is a trumpet player if and only if she is a musician. So our conditional we can write as follows: if a person is a trumpet player, then she is a musician. And our converse, well, we just swap the hypothesis and the conclusion. If a person is a musician, then she is a trumpet player. Okay? And we can determine the truth of this. Well, you see, the conditional here is definitely true, right? If you play the trumpet, you must be a musician, because a trumpet player is a type of musician. But if you're a musician, you don't necessarily have to be a trumpet player. So this statement is false. You could be a piano player, a trombone, a saxophone player. And because the converse is false, if either of these are false, then the entire biconditional is false. Because the biconditional here is saying something very strong. It's saying that a trumpet player and a musician are exactly the same thing. And that's not necessarily the case. Okay? All right, so hopefully at this point you get some sense of how to form conditional statements, how to write all of the related conditional statements, the converse, the inverse, the contrapositive, and so on. And finally, it's important that you are able to distinguish the truth of biconditional statements by breaking them apart and analyzing them separately. As always, keep working hard, ask for help when you need it, and have a wonderful day.